In this video, I'd like to continue with the math question of the day for January 19th, 2023. And we need to convert the binary number, which is base 2, this 101110, to a decimal number, which is in base 10. And for this problem, you will essentially need as a prerequisite an understanding of both of these number systems. And you'll likely be familiar with the decimal system since that's the normal system that everyone uses. But the binary system is often not taught in schools. So this is certainly something worth learning because it will help deepen your understanding of the base 10 system. But if you are interested in computers, computers use a binary number system as well as a hexadecimal number system. But this might be a challenging problem if you've never seen a base 2 number or have never seen a conversion between different bases. But once you see the general idea, it's not overly difficult. So at this point, I encourage you to pause the video, give this your best attempt, and when you're ready, go ahead and unpause the video and we can go through this together. And at this point, I will assume that you have attempted the problem. So let's start going through this together, and let's start by just rewriting our number. We have this 101110, and we're told this is a base 2 number system. And before we get into the specifics of a base 2 number system, let's just think about what a base 10 number system represents. So let's say we have the number 542.3. And with a base 10 number system, each place is a different power of 10. And this 2, for instance, is in the ones place, or the 10 to the 0 power place. The 4, this is in the tens place, or the 10 to the first power place. This is the 10 squared place, or the hundreds place. And this right here is the tenths place, or the 10 to the -1 place. And this pattern would continue. Let's say we have another number here, this 7 out in front. This would be the thousandths place, or the 10 to the third place. And this would go on forever. In either direction, they would get more negative with more and more decimals, or they would get higher and higher exponents with bigger numbers here. And the general idea with this base 10 number system is that we take this 7 and we multiply it by whatever place it's in. It's in the hundreds, or excuse me, the thousandths place. So we multiply it by 1,000, and then we add the 5 multiplied by its place value. It's in the hundreds place, so we multiply it by 100. We do the same for the 4. It's in the tens place. The 2, which is in the ones place. And then the 3, which is in the tenths place. And of course, adding these together will just get us back this familiar representation. But it's a good idea to break it apart like this so that we can see the pattern. And notice that for a base 2 number system, the main difference is that instead of having 10 at each of these spots, we would have 2 at each of these spots. And the other big difference is, notice that the binary system, or the base 2 system, is all ones and zeros. That's not a coincidence. There's a reason why there are no other digits here, like 2, 3, or 4. And essentially, whatever base number system you have, that's how many total digits you need to make the number system work. And in binary, we just need 2 digits, 1 and 0, to represent any possible number. Whereas in decimal, this base 10 system, we have 10 different digits, namely 0 through 9, and using these digits and the different place values with these different powers of 10, we can construct any number we want. So looking at this number in binary, this would be the 2 to the 0 power place. This would be the 2 to the first place. This is the 2 squared place. This is the 2 to the third power place. This would be 2 to the fourth, and this one right here would be 2 to the fifth. If we want, we can actually calculate all these, but the main idea is, just like with base 10, we take, let's say, this digit here, this 1, which is in the 2 to the fifth place, and we multiply it by that place value, and then we add it to the next digit, this 0, multiplied by its place value, which is 2 to the 4. And then we add this next place. We have a 1 multiplied by 2 to the third power. Then we have a 1 multiplied by 2 squared. We have a 1 multiplied by 2 to the first. And we have a 0, which is in the ones place, that 2 to the 0 place. And we can right away notice that these will return nothing since we're multiplying it by 0. 2 to the 5th power, if we multiply it out, we have 2, 4, 8, 16, and 32. So 2 to the 5th is 32. We have 1 times 2 cubed, which is just 8. We have 2 squared, which is 4. 2 to the 1st, which is 2. And adding these together, 32 and 8 is 40. We have 44 plus 2 gives us 46. So this number in binary, 101110, is just 46 in our base 10 system. Now, one way to check this is to essentially go backwards. If we take this number 46 and we want to convert it to a base 2 system, we can imagine sort of filling these buckets here, and I'll put in some place values. This will be the 2 to the 0, 2 to the 1st, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, and 2 to the 6th. If we want, we can also put in their actual values. 2 to the 6th, by the way, would be 64, 32, 16, 8, 4, 2, and 1. We just have all the powers of 2 in the binary system. And we can imagine filling these buckets to get 46. If each of these, you can imagine, is a bucket. Now, this place value is 64, but we have a number less than that. So we will not fill that bucket with anything. That will be a 0. But this 46, we do want to fill the next biggest bucket, essentially, which is 32. We will fill that one. So we have 1 there. And then if we wanted to fill this next bucket, we would have 32 plus 16, but that would bring us more than 46. That would be 48. So we don't want to fill that bucket. But we can fill this one, since that would just bring us to 40. And we can fill this one too, since that brings us to 44. We can fill this one because that will bring us to 46. And we don't need any more of these buckets filled, so that one will become a 0. And we can see we get back that same number, 101110. And practicing going back and forth can be a little bit challenging, but ultimately it's simple arithmetic and a deep understanding of how these number systems actually work.